The last topic from MATLAB is plotting. So there are a lot of plot functions in MATLAB. Here's a table of most of them that I could find. There are 2D plots, 3D plots, so keep in mind these might be useful later on in your future depending on what you end up doing. There are some other 2D plots, but we are going to focus on plot, semi-log x, semi-log y, and log-log. I'm going to mention fplot, but we're not really going to use it in our homework, so I'm going to kind of glance over it. Okay, so in order to plot, we need to know a couple things. First thing is, in order to plot, MATLAB opens something called a figure window. So to open up a new figure window, it's just an empty space that we can use to plot. But to open up a new figure window, you will use the figure function. It's opening up a new figure window where we can plot some data or put an axis on it, or axes, whatever, axes on it. Okay, I like to use this one where I say figure 1 or figure 2, figure 3, whatever, so I know exactly which figure I'm talking about, and I know which one because it labels them as it opens up the figure windows with the indicator here. Okay, but you can use figure, it will just open up a new figure window, but I like to indicate which one. Okay, so you can open up multiple figures at once, so you can say figure 1, figure 2, it'll open up 2 figure windows, one labeled 1, one labeled 2. If you don't use the figure function, then automatically a new figure window will open if you do plot, but it is highly recommended to use the figure function to be very explicit with what we want to do in our code. And it's just going to where things are plotted. The figure window has its own ribbon at the top of MATLAB, and you can use that to save a figure, copy a figure, edit a figure, all that fun stuff. Okay. Hand in hand with the figure function is the close function. The close function is used to close all or one or whatever figure window. So you can use close n. So exactly close 1, it'll close figure 1, etc., whichever your figure is labeled with this n. I like to use close all at the top of my script files when I'm plotting, because then it closes everything out, and then you can reopen them every time you run your code. Yeah. Okay. Let's go ahead and plot things. So I have a figure window opened, and I want to plot something. The plot function is the bread and butter of plotting for this class in MATLAB. Like I said, there are other plot functions, but we are primarily going to use plot. There's a couple ways to use it. You can say plot y. This is a vector. If you just give it one vector, it's going to go ahead and plot in x and y. X is going to be 1, 2, 3, 4, 5, 6, etc. And then the y-axis is going to be whatever your values are in this y vector. If you give it both an x and a y, then it's going to go ahead and plot the data points. So the first value in x with the first value in y, plot that data point. The second value in x, the second value in y, plot that data point, and then keep going and add a line between them until it plots all of your data points. Note x and y need to be the same length. Super important. Notice also these x and y vectors are created above, so we can say x equals 1 to 10, y equals sine of x, or whatever. We would just create them above. You can also plot multiple pieces of data with the same plot function. So here's data 1, here's data 2, if you had data 3, etc. So this will plot multiple pieces on the same graph, on the same axes. Yeah, so that's the plot function. Very basic. It will get more complicated as we add more options. Okay. Like I said, there is also fplot. Fplot works if you know exactly what function you are plotting. So if I want to plot y equals e to the 0.25x sine of x, then I can say fplot at my variable is x, it's my independent variable, and then I would just type exp 0.25 times x dot element by element notation sine of x, and I want to plot that between 0 and 10. And that's how I can use fplot. The only thing this does is this removes the need to create x and y vectors above, but that's really the only benefit. And it only works if you have a single function that is has one variable. But it can be useful. But like I said, we're not really going to use it. The last functions that you might need for this class, specifically for the project, are these log functions. So these 3 log functions allow us to plot our data with logarithmic axes. So semilog x plots the x data on a log axis and y on a linear axis. So semilog y. X is logarithmic. Semilog x. x is logarithmic. Semilog y plots the y data on a log axis, so y is a logarithmic scale. And then log plots both of them on a log axis. So if you have to plot data with logarithmic axes, you pick the appropriate one. Okay, so we can open up a new figure window. We can go ahead and put some data on that figure window, but let's say we want multiple pieces of data to be in a figure window. So there's a couple things that we can use in order to do that. The first is subplot. Subplot will allow us to plot multiple pieces of data in separate axes in the same figure window. So if I say subplot 2, 3, it's going to go ahead and break it up into 2 rows, 3 columns, where this is location 1, location 2, location 3, 4, 5, 6. It counts going across the row. Then in each of these sections, or whichever one I want to choose, so let's say I want to choose section 2. So here's the number of rows to break it into, number of columns to break it into, and then whichever location I'm talking about. So in this section here, I can go ahead and add some axes. Add some axes and plot some data. So the way this works is we would say figure, open up, I don't know, figure 1. Then I can say subplot 2, 3, 2. So break it up into 2 rows, 3 columns, and then in the second location, then I can plot X and Y. So there's my first set of data. Then I can go ahead and say, okay, now in subplot 2, 3, 4. So now in this region down here, I can say plot R, Z. And it's going to add some new data there corresponding to R and Z. Okay, so that's how subplot works. So the first 2 numbers divide it into rows and columns. Rows and columns. And then this last input goes ahead and determines which space you're trying to fill with whatever data you're going to plot next. So that's the first way. We can add multiple pieces of data to a figure. The second way, hold is used to add multiple pieces of data to the same axes. So we can do this already with the plot function like this. Just add more data, but sometimes we don't have all of our data generated at the same time. So if we are creating our data separately and we don't have it all at once, I can use the hold function. So hold would work like this. Figure 2, then I can plot X, Y, and that's going to go ahead and put X, Y on there. Let's say X, Y looks like that. And then I can say hold on, and it's going to keep that static. And then I can say plot R, Z. And now it's going to add R, Z. And then I can add more data and more data and more data and more data by multiple plot functions, etc. And then when I'm done, I can say hold off. So hold on keeps everything the way it is and keeps adding to it. If I didn't have hold on, if I said plot X, Y, and then plot RZ, then it would go ahead and delete X, Y before it plotted RZ. But with hold on, then it keeps everything the way it is and just adds to it. Make sure you do hold off. Okay. Okay, so that's adding data to our plots. The last set of things to talk about when it comes to plotting is adding some flair to our graphs. So changing the way that our data is plotted, changing these lines, changing the colors, and adding annotations to our plots. So the first thing, let's go ahead and talk about changing the way our data is plotted. So there's a couple things we can use in order to change the way our data is plotted. The first one is line specifiers. Okay, so the line specifiers indicate the type of line. We have 4 different types of lines. Type of data markers, there's lots of different types of data markers, and the color. And there's some built-in colors in MATLAB, but we can change it to, there are, oh my gosh, I can't add, like 6 or 7 or 8 or 9 basic colors that we can easily add. Okay. Line specifiers are immediately typed after the vectors. So we would say plot X, Y, followed by the line specifiers. And it can be single quotes or double quotes, doesn't matter. When I say plotting function here, it could be plot, semilog, X, also work the same, semilog Y, etc. In fact, it's the same for fplot as well. You just type line specifiers after your limits. Okay, where we specify the type of line, the type of data marker, and the type of color. We can specify one of them, we can specify two of them, three of them, in any order, any set of options. Okay, so here's our options for our line specifiers. Here's our line styles, data marker styles, and color. And notice they're all unique symbols. So if I want a dashed line, I do 2 hyphens. If I want cross data markers, then I choose the X. And if I want them to be plotted as green, I do G. Okay. That's how it would work. I can choose all 3 of these. I can choose one of them. I can choose 2 of them. I can type them in any order. So if I want to go ahead, plot X comma Y, line specifiers. If I want just a dashed line, I can just do dash dash. If I want a green dashed line, I can say G dash dash. It could be dash dash G, doesn't matter. If I want green plus signs, I can say G plus. If I want that with a dotted line, I can go ahead and add a colon. So we literally just pick one from each category and then include it as many as we want or as little as we want in any order in our single quote or in our double quotes or single quotes. Either way, doesn't matter. Yeah. So this will plot X and Y with a green line, plus data markers, and then it'll do a dash line between them. So that's what that data would look like. Yeah. And notice all of our symbols here are unique. They are mutually exclusive. So that's why it doesn't matter, because if it sees a G, automatically it has to be a G for a green color. If it sees a plus, automatically it's going to plus sign for a data marker. So that's why it doesn't matter the order that we type them in. Yeah, so these are our main choices for plotting. We also have a couple additional properties. We can go ahead and modify the line width, the marker size, the marker edge color, and the marker face color. So we can make our data a little bit more, I don't know, schnazzy. It's the best word I can come up with right now. These ones are typed one at a time following our line specifiers. So I can say plot X comma Y. Let's say I want to go ahead and make my dash line, cross data markers, and green. And now I want that line to be a lot thicker. Then I can use the line width property. So I just type line width, and then however wide I want my line to be. The default is 0.5, so let's say I want my line to be a width of 3. So now my dashed line is going to be a lot thicker than if I just had my line specifiers. Okay, if then I want to also make my marker size, let's say I want that to be, I don't know, larger. The default is, I don't know, but let's say I want it to be 10. So now I want them to be really big. And then lastly, let's say I also want my marker face color or marker edge color to be black. Okay, if I want to go ahead and change these 2 colors, marker edge color, marker face color, I can just use these colors up here as well. So there we go. So this is using multiple properties in order to modify the way my data is plotted. Remember, the way my data is added to the graph. So for this one here, my line specifiers might be a solid line, blue, which is honestly the default. This second one here, my data marker or my line specifiers might be a circle data marker, a dash line, and it's orange, which isn't one of our options. It is a default color in MATLAB. It automatically, if there's more than one line plotted, it will give it a different color. But let's say it's yellow. Yeah, that's how it's added. The last thing is annotations. So here I have this graph. I have this axis here. This is what plot will do. It will add these lines. Add that figure, add the data. The title, legend, X label, and Y label are something we need to also add with some annotation functions. So our annotation functions are listed here. So if we want to add a title, we literally just type title followed by what we want the title to be. If I want an X label, I type X label followed by whatever I want the label to be. Y label, etc. I can add a grid by saying grid on or grid off. So grid on puts a grid on the graph, grid off takes it off. If I want to put text, I can add text. So if I say text XY, so let's say X is 3 and that's 2. So it'll go to 3, 2, and it'll add the text here in this spot. Add text here. If I want to add a legend, then my first line is going to be denoted by this string. My second line is denoted by this string, etc. As many lines as I have. We can also change the location of a legend by using the location option. So literally typing in the word location. And then there's a couple different options. MATLAB uses north, south, east, west, northwest, northeast, southeast, southwest, etc. Or there's a best option that I sometimes like to use. And lastly, the axis function changes how your data is presented. So xmin, xmax says, okay, how do you want it to zoom in on your x axis? And then ymin, ymax indicates how you want it zoomed in on your y-axis. Note these are 4 numbers typed in brackets, typed in an array. So keep that in mind. Okay, so if I want to go ahead and completely plot something, I can say figure 1 subplot. Cannot type subplot. Subplot. 1 row, 2 columns in the first location. So it's going to open up a figure, 1 row, 2 columns. In my first one, plot x comma y. Plot it as a red line that's dash dotted with circle data markers. Circle data markers. Dotted, dash dotted line. I obviously didn't draw that line. And then I can say title. Data set. And it's going to say data set right up here. I can say X label. Time in seconds. So we'll do time, seconds, add that there, Y label, etc. Add to it. And then I can say subplot. 1, 2, 2. Plot R, Z. So we'll go ahead and put data here. Add a title that one. Add a title, add an X label, add this, add a legend, anything. So our plotting can get pretty long. It's a lot of typing, a lot of copy pasting, changing things. But it is pretty linear. Literally, in this figure, what do I want to put? This subplot, break it up into regions. Plot this data, add this title, add this X label. Okay, now plot this in this region, add this title, add this X label, etc. And eventually, by the end of the day, you add everything and you have a very wonderful, nice looking figure that you can go ahead and copy and paste into a report or into some other document.